All right, everybody, this is part 3. We're going to talk about some interesting features of inverses. So here in front of you, you see two functions. A function f of x equals 2x minus 3 and its inverse. The inverse of f of x is x plus 3 all divided by 2. So there's going to be some features that emerge when we evaluate these inverses. If I were to try to find, say, f of 5, what that's asking me is if I were to plug 5 in for x, what do I get as a result? 2 times 5 is 10, minus 3 is 7. Well, let's go over to our inverse and see what happens if we were to plug in f of 7, f to the negative 1 of 7. Well, what that's telling me to do is to take that 7 and plug it in for x. That would be 7 plus 3 over 2 for a final answer of 5. What I'm hoping you're seeing here is that if we plug in one number, say 5, and get an output of 7, if we were to take that output and make it our input in the inverse, it will have the opposite output, right? The output that we saw as the input from our original functions. So in other words, the values of our variables can switch. Sorry, not even can. Cross it out, Waz. Will switch, right? Inputs and outputs are flipped, right? The input in an original function is will lead to an output. If we use that output in the inverse, the output of that inverse will be the same as what we plugged in to the original function. There's some other features. One important one, these are the two functions that we have up above. And what we see there is that they are symmetric about a specific line. This line is y equals x. Similar to what we saw up above, if I were to pick a specific point I'll use my red graph here. This point has the coordinates for 5. Well, on the other graph, the point 5, 4 is included. And again, just like we saw above, inputs become outputs, outputs become inputs. This happens on more complicated graphs. So for example, here we have y equals x cubed and y equals the cubed root, of x. Again, even though it's more complicated, we are still symmetric about the line y equals x. And finally, where this really shows its use in this particular unit, on the right here, I have y equals 2 to the x, an exponential, and on the right, in red, y equals log base 2 of x. And again, these are inverse functions, and again, they are reflected over the line y equals x. So that's the big idea with inverses. Thanks for your attention.